LeetCode 1768, merge strings. Alternately might seem like a simple string shuffle, but picture merging two live input streams or alternating sensor feeds. It's a duck-sized problem with big league patterns in real-world data handling. Our goal? Clean, efficient merging. Brute force works, but can we trim the fluff and quack out something faster? Let's wade into our first approach. Brute force. It's not elegant, but it's honest. We'll just go character by character, taking one from each string in order. Let's code it out and see what happens. To keep things fast and flexible, I'm reaching for a dynamic string builder. It'll let us tack on characters without worrying about slowdown. We'll use a single index to track our position in both strings simultaneously. Since we're merging by position, one counter does the trick. We'll keep looping as long as there are characters left in either word. That way, even if one ends early, we don't lose the rest. Inside the loop, if we're still within the bounds of word 1, we grab that character and tack it onto the result. Same goes for word 2. If there's a character at this index, we drop it in right after word 1's character. Once we've handled both for this position, we bump the index and move to the next pair. After we've merged every character, we just convert the builder to a full string and hand it back. Time-wise, this is big O of n plus m, one sweep through each string. For 100 characters each, that's just 200 steps. Space is also O of n plus m since we're building the result. No fluff, just clean logic. But what if we want to cut out even more overhead? Right now, we check bounds at every loop. Feels wasteful. Instead, let's use two separate pointers to track progress more directly. That should make the alternation smoother. Let's build it. We still need a structure to collect our merged string, so I'm sticking with a dynamic string builder for efficient appending. This time, we'll set up two pointers, one for each word, to follow our position independently as we work through the input. With both pointers ready, we'll start pulling characters from each word, one after the other, while both still have content left. Once one of the pointers reaches the end, we check if word 1 still has leftovers, and if so, we toss them into the result. And same logic for word 2. If anything's left, it gets appended right after. Once that's done, we return the completed string we built. This still runs in big O of n plus m, 200 steps for 100 characters each, but now it's smoother and duck-friendlier. We lose the repeated bounds checks, but keep the same memory usage, just cleaner execution overall. Let's tighten this up even more. Dynamic builders are handy, but they can resize internally, adding cost. What if we knew exactly how much space we needed and filled it directly? That cuts the overhead entirely. First, let's store the lengths of both input words. Then we'll prep a char array that's exactly the size of the final result. No guessing, no growth. We'll set up 3 pointers, one for each input and one to track our right position in the output array. As long as both pointers have characters left to process, we alternate, first word 1, then word 2, one character each. When one string runs out, we check if word 1 still has more and copy over the remaining characters directly. Same deal for word 2. Any leftovers get dropped in to finish the merge. After the merge is fully built, we just convert our char array into a string and return it. This version nails it. Still O of n plus m time and space, but now the memory is perfectly sized. No dynamic growth, no wasted steps. It's lean, fast, and ideal for high-performance needs or technical interviews. Let's recap. We kicked off with a straightforward merge, easy to follow, but repetitive on bounds. Then we leveled up with 2 pointers for better control and smoother flow. Finally, we pre-allocated our space and built directly into it. No resizing, no overhead. In real-world systems like message passes or stream processors, this kind of precision matters. The final version isn't just fast, it's interviewer gold. It shows you think in systems, not just syntax. So here's your challenge. Where else might you need alternating merge logic? And can you tell when it's time to shift from simple to efficient? Keep at it, and keep sharpening those coding instincts.